Once we defined a consumer's choice set and a consumer's tastes, we could ask, which bundle will the consumer choose if she does the best she can given her circumstances? We're now at the same point with producers. We've defined the producer choice set through the use of the production frontier, and we've defined the producer's tastes through maps of isoprofit lines. We can now ask, which production plan will a profit-maximizing producer choose? In panel B of graph 11.1, we mapped out this production frontier. It was a production frontier that exhibited the property that initially it got easier and easier to produce, and eventually it became harder and harder to produce. So as we move up the production frontier, the slope initially starts shallow, becomes steeper, and eventually becomes shallower again. In graph 11.3, we then mapped out three isoprofit lines, one corresponding to profit of $200, one to $700, and one to minus $300, all under the assumption that we have to pay $20 per hour to hire labor, and we can sell the output for $5 per pack of economist cards. Just as we did for consumers, we'll now combine the panel that represents constraints with the panel that represents tastes to determine how those two interact to result in the behavior that we can actually observe. In particular, we'll ask how high an indifference curve or an isoprofit line can the producer get to while still remaining within the choice set. In other words, how far to the northwest, which is where the higher isoprofits are located, can the producer move while not leaving the producer choice set. We can then see that the highest possible isoprofit line that the producer can reach without leaving the choice set is the middle blue isoprofit line. This isoprofit line is tangent with the production frontier at production plan A. Since the slope of the isoprofit line is W over P, and the slope of the production frontier is the marginal product of labor, the condition that has to hold at this tangency at production plan A is that W over P is equal to the marginal product of labor. There's a second way we can illustrate the profit-maximizing choice by this price-taking producer. This involves starting with the marginal product of labor curve, which is simply the slope of the production frontier from panel A. This marginal product of labor curve is initially increasing but eventually decreasing, because the production frontier in panel A has a slope that's initially increasing but eventually decreasing, and that slope is the marginal product of labor. The marginal product of labor is the additional output I get by hiring one more hour of labor. The marginal revenue product of labor, on the other hand, is how much additional revenue I get by hiring that 1 hour of labor. Marginal revenue product therefore simply converts marginal product from output units to dollar units, and we do this by simply multiplying the marginal product by price. If, for instance, I know that 1 additional hour of labor will result in 2 additional units of output, and I know that I can sell output for $5 per unit, then I know that the marginal revenue product of that worker hour is $10, the 2 units of output times the $5 I can sell the output for. In panel E, we illustrate this marginal revenue product of labor, which is simply 5 times the marginal product of labor when the price is equal to 5, and thus the same as the marginal product curve, except it's scaled up by 5 times. In panel F, we replicate this marginal revenue product curve and note that on the vertical axis we're measuring dollars, because marginal revenue product is measured in dollars rather than in output units. We can then draw a horizontal line where the wage of $20 happens. The reason we do that is because we can now ask whether it's worth it to hire the different worker hours. Each worker hour costs me $20. The marginal revenue product curve then tells me how much in additional revenue I get from hiring each worker hour. We can compare those two to see how many workers we should hire. For the first 22 workers, the marginal revenue product is less than the wage, and so I actually lose money on those workers. For the next 56 workers, up to 78, the marginal revenue product is above the wage, so I make money on those workers. Therefore, we can represent the area where I make money on workers as the green shaded area, and the area where I lose money on workers as the negative magenta shaded area. If I produce, I'm going to want to produce with 78 hours of labor, because at that point I'll have exhausted the entire positive area, and if I hire any more worker hours, the marginal revenue product falls below the wage again, which means I'll lose money on any additional worker hours that I hire. So long as the shaded green area is larger than the shaded magenta area, my profit will be positive. I'll lose money on the first workers that I hire, but I have to hire those workers in order to get to that positive area and be able to start making profit. At the optimal labor choice of 78 labor hours, it has to be true that price times marginal product, in other words marginal revenue product, is equal to the wage. But notice that's exactly the same condition we derived in panel C for the production plan A. There we said that the tangency implies that W over P is equal to marginal product. Multiplying both sides by P, we get that W is equal to P times marginal product of labor. In other words, we hire until the wage is equal to the marginal revenue product of labor. Exactly the same condition we get in panel F. There are in fact 2 points at which the marginal revenue product of labor is equal to the wage. The first happens at 22 labor hours, and the second happens at 78 labor hours. Of course, we don't stop hiring at 22 labor hours, because at that point we're only making losses on every one of the labor hours we've hired. That in fact corresponds to a tangency in the top graph in panel C that would happen at 22 labor hours. But that tangency would imply a negative profit, because the isoprofit that's tangent at 22 labor hours has a negative intercept. The isoprofit that's tangent at production plan A in panel C, on the other hand, has a positive intercept, which implies a positive profit, in fact a profit of $200. This tells us that the green shaded area is in fact $200 larger than the magenta shaded area